Welcome class to Math 1030, Unit 4B, the power of compounding. And so in this section is the first of several on finances. Okay, so how do we use finances in real life? And in order to do this section, I'm going to go over the handout, and we begin the handout with 1, the math review. Okay, so 1 is a math review. I'm going to start by, in section A, we're going to do some simplifying of expressions that involve exponents. Okay, so we're going to simplify these expressions. So Roman numeral 1, 3 to the 4th power is the same as 3 multiplied by itself 4 times. And so we have 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. Okay, so that one's 81. Roman numeral 2, 5 to the negative 2 power. Okay, so the exponent is negative, and how we simplify this is that we put the expression in the denominator of a fraction. And that will change the sign from positive to negative. And we simplify 5 squared as 5 times 5, which is 25. Now, Roman numeral 3. In this one, we're going to do 49 to the 1/2 power. So this is a new type of exponent as well, which is 1/2 as the exponent. And when you have 1/2 as the exponent, it's the same as the square root of the number. And the square root of a number, we take and see what two numbers multiply themselves together that are the same to get 49. And we know that that's 7 times 7. But it's also true that negative 7 times negative 7 is 49. So that's why we write for the answer to this one is plus or minus 7. Okay. Roman numeral 4. Is 4 squared times 4 to the 3rd. Now when you have two exponents multiplying themselves with the same base, you can add their exponents. Because 4 squared is 4 times 4, and then 4 cubed is 4 times 4 times 4, 3 times. Okay? And then notice that there's all the same base, and how many 4 times 4s do we have? We have, well, a lot of them there. So we have 2 here and 3 here. So there's a couple extras here, so we'll erase those. Okay. And so how many 4 times 4 do we have? Well, we have 5 of them. Okay. So what we can do to shortcut all this extra work here is 4 times 2 plus 3, 4 to the 2 plus 3 power. And that's the same as 4 to the 5th power. So whenever you have exponents that have the same base, you're multiplying them together, you add them together, the exponents. And so that's going to equal to 1024. Number 5. Number 5 says 7 to the 3rd times 7 to the negative 3. Okay, so they again have the same base, so I'm going to add their exponents. And when I do that, I get 7 to the 0 power. And 7 to the 0 power is just 1. Number 6 is 16 to the 1/2 power divided by 16 to the negative 1/2 power. So when we do this division and we have 16 to the 1/2 powers, let's simplify the exponents first. So 16 to the 1/2 power square root of 16 divided by 1 over the square root of 16. Okay? So the exponent 16 to the 1/2, negative 1/2, becomes 16 to 1/2 in the denominator, which is the same as the square root of 16. Okay, so we have that as 4 divided by 1/4. And when we're dividing fractions, we multiply the reciprocal to get that one, and we get 16 here. Okay, that's good for this video. Okay, in this video we're going to do part B for number 1. Okay, so number 1, part B. Back use a different color here. And in part B, we're going to solve for a known variable. So solve for x. Number 1. This is just a review of algebra. So 3x plus 4 is equal to 6 plus 4x. So we're going to solve for x, and we have two terms that have x in it, one on the left side, one on the right side of the equation, so we need to combine those together first. And the first thing that we're going to do is we're going to subtract 3x from both sides, and I like to keep things positive. So if we subtract 3x, we'll accomplish that. That will go to 0, so we have just 4 on the left, and we have 6 plus 4x minus 3x makes just x. Now we're going to subtract 6 from both sides. That will go to 0 as well. Therefore, x is going to equal to negative 2. Part 2. Part 2 has x over 5 plus 7 is equal to 13. Okay, in order to get x by itself, we have to subtract the 7 from both sides. And we get, that will go to 0 there. We have x over 5 is equal to 6. We multiply both sides by 5. And we have x is equal to 30. That's our answer for that one. Oops. Number 3. Roman numeral 3 says that we have x minus 3 quantity squared is equal to 16. Okay, so there's a couple ways of doing this problem. We can multiply x minus 3 out, but I'm going to go ahead and take the square root of both sides. So we do that, we have x minus 3 is equal to plus or minus 4. Okay, remember, it could be positive 4 or negative 4. And so we're going to take the case that of each one, x minus 3 could be equal to 4, or x minus 3 could be equal to negative 4. And when we do that, we'll solve each of these equations separately by adding 3 to both sides of this one. That will go down to 0, x is equal to 7. Here I'm going to add 3 to both sides again. That will go down to 0, x could be equal to negative 1. Okay, so it has two answers for this one. X is equal to 7, x is equal to negative 1. Roman numeral 4. We have x squared plus 4 is equal to 13. When I subtract 4 from both sides, x squared is going to be equal to 9. And then we're going to take the square root of both sides. X is going to be equal to plus or minus 3. Because both positive 3 and negative 3 could be the answers to that one. Number 5. Number 5 has x cubed minus 5 is equal to 22. So we're going to add 5 to both sides to get x by itself. This will go to 0. X cubed is going to be equal to 27. Okay, so we need some number multiplied by itself is equal to 27. So in order to do that one, we have to take the cube root of both sides. And that means that we have x is equal to something times itself 3 times to 27 would only be the answer of 3. Because 3 times 3 is 9, 9 times 3 is 27. Okay, so that's that video there. Now that we're done with our little math review, let's go ahead and get into the main lesson for this one. Part number 2, what is simple interest? Okay, so simple interest happens when interest is paid only on the original investment. On an original investment. So, and not on any interest paid later. At later dates. Okay, so this is a section where some of you might have seen before, where we have, I'm going to invest $1,000 into an account that pays 5% annually. And so simple interest is going to be interest paid only on the original investment. Part A is going to have us do an example problem where we use simple interest. Okay? So it says you deposit $400 into an account with an annual interest rate, or APR, of 5%. Calculate the amount of money you would have after 5 years, assuming the account earns simple interest. Okay. So what we're doing here is we're going to deposit $400 into an account. Okay. After year 1, after our first year, okay, we have 5% of that will be added to us. So we need to calculate what 5% of 400 is. So multiply that by 0.05, and then we find out that that's $20. So now it's going to be added to us, so that means we're going to have $400 plus $20. After the end of year 1, we will have $420 into our account. Okay. Now, simple interest does not take interest on the $420, it just keeps paying us $20 every year. Okay. So after year 2, we had $420 to start with. We're going to add on the other $20, which is the simple interest, and we'll have $440. After year 3, we have $440. We're going to add on $20 more, and we're going to get $460. After year 4, we have $460. We're going to add on another $20 of interest, simple interest, and we're going to get $480 as we end up with that. After year 5, we have $480. We're going to add on the $20, and then we'll have $500. Okay, so after year 5, with the simple interest account, we will have $500. Okay. Number 3. What is compound interest? So compound interest is interest paid on both the original investment and all interest that has been added to it. Okay. So in an example here, we have the same situation where we're depositing $400 into an account with an annual interest rate of 5%, APR, annual percentage rate. Now calculate the amount of money you'll have after 5 years, assuming the account earns compound interest. Okay, so when we deposit $400, okay, after year 1, we'll have the same situation as before. We take $400, multiply by 0.05, and we get $20. Okay, so after the first year, I'm going to add on $20. So I'm starting out with $20 as my first year, after my first year into year 2, and this is where I'm going to take the $420, and I'm going to calculate interest on that amount. So we multiply that by 0.05, and when we do that, we get $21. Okay, so we're earning more money if we do compound interest calculations, and so when we do that, we get $441 at the end. So after year 1, we'll get $420, and after year 2, we're going to get $441. Okay, so after year 3, we start out with $441, and I'm going to go ahead and multiply this by 1.05, because we know that that will just give us the actual amount balance after year 3, instead of having to find out 5% of what the balance is and then adding that back onto what the balance is. So this is the shortcut that we've talked about before in class. And we multiply that by 1.05, according to my calculations, we get $463.05. After year 4, we take our 463.05 and then multiply it again by 1.05, the original amount plus on 5% of what happens at the end here of this year. and I get $486.20. $486.20. After year 5, at the end of year 5, we take our $486.20, multiply by 1.05, and we'll end up with $510.51. Okay, so when we do compound interest, the bank or the account person will have to pay a little bit more money, because that is taking the interest calculation off of the current balance, and that's called compounding the interest. Okay? So when you calculate interest using the current balance, you're compounding the interest. Okay? So part B talks about a formula for compound interest, for interest that's paid only once a year. And we've seen that before in other places. So notice that I'm again multiplying by 1.05 here several times, and every year I'm doing that. Okay? And so every year I'm going to multiply by 1.05. So that means I'm going to take 1.05 and raise it to a certain power, the power of the years. Okay? So the formula, compound interest where compounded annually, which means the interest is calculated only annually, not more frequently. Is given by A equals P times 1 plus the APR to the Y power. Okay, so here's my formula. So the variables each mean something. So A is equal to the accumulated balance after Y years, or what we're looking for. Okay, P is going to be the principal, starting principal, or the amount of money to start with. Okay, amount of money that you start investing in. APR means the annual percentage rate. That's how much they're going to calculate for your interest. Okay? They're going to take a percentage of your investment. Y is going to be the number of years. Okay, so Y is the number of years that you're in on this. Okay, next. That's a good video for now. Okay, now we're on number 4. The formula for compound interest paid more than once a year. So part 4 here. Now before we only studied when the compound interest was being paid once a year, meaning that interest was compounded annually or calculated annually and then paid. So compound is like the interest calculated and then paid to your account. So more than once a year you can have accounts that pay you interest more than once a year. They could be compounding interest or calculating it and paying it to your account every month, every quarter, every day even. Okay, so let's see. The more it's compounded, then the more money you get. But more as you compound it more and more frequently, the less and less money is given. Okay, so the formula is actually given in the book, and we won't talk any about the derivation, but the amount of money that you'll have in your account is equal to the principal times 1 plus the APR over n, or the number of times you compound annually. So that you take your percentage of interest divided by the number of times you compound annually, and you take it to the power of n times y, or the number of times you compound it yearly, to see how many the total number of compounds there are in the whole process. Okay, so all of the variables are the same as above, Like A is the amount that you invest, you want to talk about with the balance. P is the amount you invest. APR again was the percentage rate, and N is the number of times you compound. Y is going to be the number of years you do this for. Okay. So in part A on the last page, we want to find the balance of an account that has where $1,000 is invested for 5 years, APR of 3% with monthly compounding. Okay. So that's a lot to say, but the amount is what we're looking for. The principal is how much is invested. In our case, it was $1,000 multiplied by 1 plus, now APR was the annual percentage rate as a decimal again, so it's 0.03, divided by the number of times compounded per year. So if it's monthly, then you'll do 12 times per year. Okay, so times 12, and then that's going to be for 5 years. Okay. So we're going to simplify this here, 1,000. I'm going to start by simplifying this part in here. Times 1 plus, now 0.03 divided by 12 is 0.0025. And then 12 times 5 is 60, so you're going to be 16 compounds total for our calculation. 1 plus 1.0025 to the 60th power. And then we're going to do that in our calculator, so this last part is going to be about 1.16. Okay, and then we find out that times that by 1,000. In our calculators, we still have this expression, and we multiply that by, which is about 1.16, we multiply that by 1,000, and we get a total of $1,161.62. Okay. Notice that that was a interest over the 5 years of $161. Part B for this one says find the balance of an account where $1,000 is invested for 5 years with an APR of 3% and daily compounding. So every day you're going to calculate interest and pay it to your account. Okay, so the amount is going to equal to $1,000. So the amount is going to be more than just compounding it monthly. Let's see how much more. 1 plus, multiplying by the quantity, 1 plus, now APR is 0.03 over 12. No, not 12 this time, because we're going to go with daily compounding. So how many times a year is that? Well, we just used 365 to the 365th power times 5 years. Okay. All right, so what is that going to be? So we have $1,000 times the quantity 1 plus. Now 3.03 over 365 is a very small number. I'm starting with a small number, dividing into smaller parts. So it's 4 zeros there and 8,219 to the 1825. So 365 times 5 is 1825. Oops. Okay, so we're going to back up just a bit here. And I want to just add these together. So it's $1,000 times 1.0008219 to the 1825. Okay, and so when we find this right here, we get 1.16 again, about. And we're going to keep that whole thing right here as the long decimal in our calculator. So we multiply that by 1,000. We will get $1,161.83. Okay, so notice that when you compound monthly, or 12 times a year, you have $1,161.62. But compounding it every day, you get a little bit more money, but it's only about 21 cents more. Okay, so there's a 21-cent difference when compounding daily. Versus compounding monthly. Okay, so it's not very much different with however often you compound from 12 to 365. Okay, so there's that video. Okay, number 5 for our video is we're going to talk about annual percentage yield. Or what they call APY. Okay, so it's different than APR. Annual percentage yield. So APY is the actual percentage by which a balance increases in 1 year. Okay, so let's say that you deposit $1,000 and you get $1,100 after the year, after interest is compounded, and then you have a $100 increase, and then what percentage is that of $1,100? Okay, so we're going to use this example. So in part A is our example. We're going to find the annual percentage yield of a bank that offers 2.25% and quarterly compounds. Okay, so there's a problem like this on the homework. In order to find that annual percentage yield, we're going to have to just give an example balance, an example investment, and then see what percent it is. Okay, so we're going to say that an easy investment is $1,000. So we're going to put $1,000 into this bank account that offers the APR of 2.25% and quarterly compounds. So after 1 year, we're going to calculate how much we get. Okay, so we're going to multiply that by 1 plus the APR as a decimal is 0.0225 divided by 4 because we compound quarterly, and then we do 4 times to the 4 times 1 power because we're only going to do it for 1 year. Okay, so let's see how much money this gives. So $1,000 times 1 plus and 2, and the 2.0225 divided by 4 is 0.005625. Okay, so we're going to take that quantity and raise it to the 4th power. So we have $1,000 times 1.005625 to the 4th power. Now this part right here we do on a calculator, and we keep the digits in there because we're going to eventually multiply by 1,000, and we get 1.023. And when we multiply that by 1,000, we get $1,022.69. Okay, so I round to this 100th place because we're dealing with money. All right, so that's the total after a year of investing $1,000 with this setup. Interest rate is 2.25%, compound quarterly. Now the annual percentage yield, the APY, is equal to the money that is made, which in this case is just $22.69, divided by the ending balance, $1,022.69. Okay, so when I divide those two numbers together, I get 0.022, or we can call that an annual percentage yield of 2.2%. Okay. Okay, number 6, our last one for this handout. We want to plan ahead and use compound interest to help us. Okay, so what we're going to do is we're going to find a situation. Suppose we want to invest money into an account with an APR of 3%, which is compounded monthly, and leave it there for 18 years. Say you're going to do a college fund. How much would you have to invest now for there to be $100,000 after 18 years? And so in order to do this, we're going to kind of just think about solving for the principal amount and convert our equation to the principal is equal to something. And so when we do that, we have to take the whole right side of the 1 plus APR over n times n to the y and put it and divide it both sides. Okay, so we have 1 plus, let's go back here. So we have 1 plus the APR divided by n to the ny, and we're going to put that's all going to be under our a, or the amount that we want. Okay, so we want the amount at the end, and given a certain principal, we invest now. So we don't know how much we're going to invest now, but we want to have $100,000 at the end. So take our $100,000 divided by 1 plus, now the APR in this case was 0.03 or 3%. We're going to compound it monthly, so we'll divide by 12 to the 12 times, and the years are going to be 18 years because we want to do this, put this money and leave it there for 18 years. Okay, now let's simplify this. The principal is going to be equal to $100,000 divided by 1 plus, now 0.03 divided by 12 was going to be 0.0025. Okay, 12 times 18 is 216. Okay, and now let's go ahead and keep going in our simplification. $100,000 divided by 1.0025 to the 216 power, which is the same as $100,000 about, divided by 1.1749. Okay, and so when we divide this number with our calculator, we can get P is approximately equal to $58,314.11. Okay, so in order to get $100,000 18 years in the future with this account setup, 3% APR, compounding monthly, we need to invest $58,000 now. Okay, so that's our lesson for today.